All right, so here are the ions. Again, highly recommended to put them on flashcards. So here are your polyatomic ions. All right, so here are the polyatomic ions to memorize, and I have them in alphabetical order. All right, so the first one is acetate, and that is C2H3O2 minus 1. So again, more than one atom with a charge. This is going to be the list of the polyatomic ions that you have to memorize. Second one, ammonium. Ammonium is NH4 that has a plus charge. That is the only polyatomic ion that has a positive charge that you will need to memorize. Third one, carbonate. Carbonate is CO3 minus 2. Fourth one is chlorate, bromate, iodate. I put them together because you have your periodic trends. They're in the same column in the periodic table. And so you have your chlorate. I put it in there for chlorate. I could have put it in there for bromate, but I do it in the alphabetical order starting at the top of the periodic table. So chlorate is ClO3 minus. Bromate, I'm putting it as the same number 4. Bromate is BrO3 minus, and then iodate is IO3 minus. All right, so that's periodic trends. Chlorate, bromate, iodate, ClO3 minus, BrO3 minus, IO3 minus. Fifth one, chromate. CrO4 minus 2. And again, 2 minus, minus 2, I don't care. All right. Number 6, cyanide. And that is Cn minus capital C, capital N minus, that is a carbon, nitrogen, more than one atom, minus charge. 7 is hydroxide, and these are the two that when you name them, they're going to end in IDE. It's going to end in cyanide, it's going to name in hydroxide, but they are not binary. Hydroxide, and that is OH minus. Number 8 is manganate. Manganate is MnO3 minus. Nitrate is number 9. And that is NO3 minus. Number 10 is phosphate. That is PO4 minus 3. And then finally, number 11 is sulfate. SO4 minus 2. All right, and so there's going to be a lot of naming questions based on those polyatomic ions. All right, so now we're going to have a chart in order, we're going to make those 11 even more things that you need to know. All right, I'm going to make a chart and give examples. So you're going to have your hypo, and then you're going to have your base name, and then it's going to end in ITE. All right, and this is minus 2 oxygen atoms. All right, and then you're going to have simply your base name ending in ITE, and that is -1 oxygen atom. And then you're going to have your ATE, and this is your memorized name. So any of the names up above that end in ATE, your sulfate, phosphate, nitrate, you go up, bromate. All right, so that is your memorized name here in this chart that I'm making. And then you're going to have your per, and then 8. And this is +1 oxygen. All right, so this little chart here is going to make all of your 8s more than one thing that you actually know. So let's do an example. Let's go to chlorate. All right, so I'm going to have chlorate. And I look right up above, or I have now memorized it, making my flashcards, or however you memorize it. And that is ClO3 minus. So I have that memorized. I know chlorate is memorized. So that is right here in my memorized name. That's where I'm at in this chart. That's chlorate, ClO3 minus. So if I go up one, I have chlorite. All right, so I just moved up to the chlorite, and this says -1 oxygen atom. So what that means is I remove an oxygen atom. I don't do anything else. Charge is the same. So this is ClO2 minus. So that now you know is chlorite. All right, I'm going to go up one more, and I'm going to have hypo and chlorite. That says subtract 2 oxygens. So that means from the memorized name, I'm going to subtract 2 oxygens. All right, so now I have ClO3 minus that I have memorized. I'm going to subtract 2 oxygens, change nothing else. And I have ClO minus, and that is hypochlorite. All right, so back to my memorized name of chlorate. If I go down, I have to add an oxygen, and that is going to be perchlorate. So now I have perchlorate. And that means I have to add an oxygen. So now I have ClO4 minus. All right, so again, this is the one that you have memorized in your chart. So you need to know if I wanted that to end in ITE, I subtract 1 oxygen. If I wanted that to have the prefix hypo and end in ite, I have to subtract 2 oxygens. If I wanted to make that a perchlorate, I have to add 1 oxygen. And so now your chlorate is now 4 things. It's not only chlorate, it's chlorite, it's hypochlorite, and it's perchlorate. So you need to know the formula for all of those 8s and understand that chart to make it the ite, the hypoite, and the per 8. All right, your elements on the periodic table. You will need to know many of your elements on the periodic table. All right, so here are the ones you need to know. Again, periodic table is always given. You just need to know what the name of the element is. All right. All right, so no element names. For atomic number. All right, 1 through 30. So you need to know the first 30. All right. Then 35 through 38. And then 42 to 48. 50. 53 through 57. 74 to 80. 82 to 83. 87 to 89, 92 and 94. All right, and so any of the other ones, you do not need to know what the symbol stands for. All of the other ones, you need to know H, hydrogen, He, helium, Li, lithium, Be, boron, Be, beryllium. All right, so you need to know the first 30, okay, and then there's your atomic numbers. All right, so 92 is a U. You need to know that's uranium. So those are the ones that you need to know the name for the symbol. Again, periodic table is always given. You need to know the 7 diatomic elements. All right, and so the 7 diatomic elements, that is going to be on the periodic table. You're going to have your nitrogen, you're going to have your oxygen, you're going to have your fluorine, you're going to have your chlorine, you're going to have your bromine, and you're going to have your iodine. And I wrote it where it is on the periodic table. And what's nice about that is the 7 diatomic elements makes a nice 7. However, when you add these up, you only get 6. All right, do not forget that hydrogen is also diatomic. So those are your 7: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then the 7th one is hydrogen. So if the problem says you've got hydrogen gas, you have to write H2, nitrogen gas, N2, oxygen gas, O2, fluorine gas, you got F2, chlorine gas, Cl2, bromine gas, Br2, bromine liquid, bromine's a liquid at room temperature, Br2. You got iodine, iodide solid, iodine solid, you got I2. All right, so those are the 7 diatomics. Your metal ions that you need to memorize. All right, and these are your transition metals that you need to memorize. You already have your +1 column, your +2 column, your +3 column. No exceptions for the +1 and the +2 column. All right, and so zinc is Zn +2. So that is the only one. It's not multiple. Nickel is Ni +2. Silver is Ag +1. Silver is an odd one. Most of your transition elements have a stable +2. Silver is not included in that most. Silver is only a +1. Cadmium is Cd +2. And platinum is also +2. The multiple ions that you need to memorize, multiple ions, all right, so that means that you have your copper. So we already went through copper. Copper is +1, copper is +2. You have to know that your iron is +3, iron is +2. I should put them in number order, whatever. So you had your +2 and your +3 for your iron. You've got tin, that is +2. You got your tin, that is +4. So we went through those already. Make sure you know those multiple oxidations. And remember, you can call it the ick and the us. So here is the cuprous, this is the cupric, this is the higher, so this is the ferric, this is the ferrous, and this is the stan us, lower, this is the stan ick, higher. So when there are 2, then the lower one is the us, the higher one is the ick. When you're naming it, copper 1, copper 2, that's fine. But if I give the name, it could be cuprous fluoride. You have to know that the lower copper is +1. All right. Now we're going to name oxyacids. All right, so that means that you're going to have an acid. All acids are neutral. All right, no overall charge. All acids are neutral, and all acids start with H. All right, so let's do the one, we'll do two that everyone knows, or most common two acids in the lab, HCl and H2SO4. All right, and so we're going to name these acids. Now, HCl, I said oxyacids. HCl is not an oxyacid. All right, an oxyacid has oxygen, acid with oxygen. All right, so H2SO4, that is an acid. It starts with H, it's neutral. All right, it's got oxygen, it's an oxyacid. HCl, it's an acid, it's neutral, starts with H, not an oxyacid, doesn't have oxygen in it. All right, so I'm just naming two acids that you should already know the name of, but if not, fine. HCl, if you had a high school chemistry class, it's the acid you use in lab, if you had a lab. All right, so this is hydrochloric acid. It is very important to know this acid because it's going to tell us how to name this acid. All right, H2SO4, again, a very common acid. It is battery acid. This is sulfuric acid. It is nice to go to things that you should know, and that will give you the rules for naming. All right, so note that hydrochloric acid is binary. So the binary means you have only two elements, and the first one has to be H, and then one other element. In this case, it was the chloride ion. So that is your way you're going to name a binary acid is you're going to have the prefix hydro, and then it's going to end in ic acid. For the sulfuric acid, you see that you had memorized sulfate up above. You have sulfate memorized. As SO4 minus 2. And your H is in the plus 1 column. Again, it's not a metal. It just thinks it's a metal sometimes. All right, and so you have your hydrogen that is in the plus 1 column. And that is why to make it a neutral oxyacid with a minus 2, you had to have two H's to make it neutral. So H2SO4. And then also note that now we don't end in ATE, we end in ic acid. And so you have to drop the 8 and add ic acid. All right, now we had our chart, and then it could have ended in ite instead of 8. All right, so if we went to H2SO3, all right, so we have our chart. So we know that now we know that SO3 is minus 1 oxygen. We had the SO4 minus 2, and now we have the SO3 minus 2. We dropped 1 oxygen. And so this is sulfite. All right, so when you lose an oxygen, it becomes the ITE. So this is sulfite. Now to make that into an acid, we still have the minus 2. Again, when we go from A to ite, we are just changing the number of oxygens. The overall charge of that ion does not change. All right, and so this is sulfite. Now the rule for the ite is you drop the ite and you add us acid. And so this is sulfurous acid. Now, if you don't add the UR and you just call this sulfurous acid, that is 100% going to be counted correct. All right. So anytime that you make an acid, it has to be neutral. So you have your charges. The H's are plus 1. All acids are neutral. If you had a ion that you memorized that end in 8, When you make the acid, the ate becomes an ic acid. If it ended in ite, it becomes an us acid. All right, so if we go back to the examples we had for the chlorine. So remember, we had ClO3 minus, that was the chlorate. We had the ClO2 minus, that was the chlorite. We had the ClO minus, that was the hypochlorite. And we had the ClO4 minus, which was the perchlorate. Now we can convert all of these into acids and name the acid. All right, so all of these are -1. To make the acid neutral, we simply need one H. And so the acid is simply put an H in front to make it a neutral compound. All right, so these are all ions, not compounds. They have a charge. All right, so when we make an acid, all acids are neutral. And so you have your HClO, you have your HClO2, you have your HClO3, and HClO4. And now you name them. Again, to name them, if it is ate, we'll start with the chlorate. We drop the ate. We add ic acid. And so this is simply chloric acid. Again, here we drop the ate, we add ic acid. This is perchloric acid. All right, up here we have the ite. Remember, you drop the ite and you add us acid. And so this is chlorus acid. And this is hypochlorous acid. All right, so now you can name all kinds of acids. All right, so if we wanted to name the acid HBr, now we're back to a binary acid. And again, you should always fall back on HCl. That is one that you should know for sure. We're going to use it in lab many, many times. HCl you should be very familiar with. And you know that's hydrochloric acid. So if you can name that as hydrochloric acid, then you simply name this as hydrobromic acid. So again, your binary acids, binary, two things, H and one other thing, one other element. All right, that is going to always be hydro and then ic acid. So hydrochloric acid, hydrobromic acid, hydrofluoric acid. All right, now we can go to H2S. All right, so now we have to name H2S, not H2SO4, not H2SO3, not H2SO2, not H2SO 5H2S. You have to recognize this as a binary acid and follow the rules. So you have to say, I have a binary acid. I remember my binary acid, hydrochloric acid. Okay, so now I know how to name a binary acid. And so this is hydrosulfuric acid. And if you just call it hydrosulfic acid and don't put the UR, again, I don't care. The key is it has to have hydro and end in ic acid with the base name for the sulfur. If you have, very interesting one, if you have H3N, all right, so a name for this, if I would say name this acid, all right, so it's not an acid, but if I said name this acid, you would follow the acid rules, and this would be hydronitric acid. No such thing as hydronitric acid. All right, that would be following the rules, but that is not an acid. All right, same with this one, H2O. Okay, if I say name this acid, all right, so said all kinds of bad things. Okay, so it's like it's not an acid. This is water. All right, the name of H2O, the only correct name for H2O is water. All right, there's a lot of names for water. If you said name this acid, this would be hydroxyic acid. The questions I like to give, I would say the incorrect name for this is hydroxyic acid. What is the correct name? All right, so hydroxyic acid, you can get the formula of H2O. Of course, the correct name for that is water. I could say the incorrect name for this is dihydrogen monoxide. So this is dihydrogen monoxide. All right, okay, you have hydrogen, non-metal, oxygen, non-metal. You have a molecular compound. You use Greek prefixes, dihydrogen monoxide. All right, again, that is not the proper name for H2O. It is water. If you simply had hydrogen oxide. Again, hydrogen likes to act like a metal. If you had hydrogen oxide, the formula you would come up with is hydrogens +1, oxygens -2. You come with H2O. That is not the proper name. The proper name is water. All right, so you can have a lot of wrong names for H2O. And so some of my favorite questions are, this is not the correct name. What is the correct name? The same thing would go up here for your N with 3 H's. All right, I would say hydronitric acid is the wrong name for this. It's actually the wrong formula for this. It is written as NH3, which you now need to know is ammonia. So that is your ammonia, NH3. Now NH4 plus is ammonia, but ammonia is NH3, and that is actually a base, not an acid. All right, and so hydronitric acid, not a correct name, so I'll put an X there. Again, this is not a correct name, not a correct name, not a correct name. This is water, this is ammonia. All right, so there are a lot of flashcards that you're going to need to make. So let's name a couple of things here. So if I wanted to name MgSO4, so it's simply name. So there's going to be a lot of this on the test to name various compounds. All right, so again, magnesium, that's one of the elements that you need to know the name for. So you have to know that Mg is magnesium. And your SO4 and magnesium's in the +2 column. So you have your periodic table, you have Mg, it's in the +2 column. You have your memorized sulfate, which is SO4 -2. And so as long as you know Mg is magnesium and SO4 -2 is sulfate, you just give magnesium sulfate. Now, if I had SO3, all right, so this one is very tricky because some people will name that as sulfite. SO3 is not sulfite. All right, what is sulfite? Well, sulfite is SO3 -2. All right, so SO3, now you have to know that you have a nonmetal, you have another nonmetal, and you think, oh, when I have my two nonmetals together, how do I name it? Go back to the ones you know. You know CO, you know CO2. All right, here's your two nonmetals, and that's how you name it. Carbon monoxide, carbon dioxide. This is not carbon, this is sulfur. So this is sulfur trioxide. All right, so there's a huge difference between sulfur trioxide and sulfite. Huge difference. All right, so you have to be very careful with, is there a charge given? Is this one of my polyatomic ions? Or is it neutral and it's a compound and I name it like I do my two nonmetals? Examples there. All right. If we wanted to name, let's do HNO3. Okay, very, very, very common acid in lab. All right, how do I know it's an acid? I immediately said acid. Well, it starts with H and it's neutral. If it starts with H and it's neutral, you've got an acid. All right. Oh, the other thing for acids, all acids are aqueous. All acids are aqueous, which means they are in water. And so this is nitric acid. All right, so HCl, aqueous gas. This is hydrogen chloride gas. All right, so in class, if somebody says they want some HCl, they're not looking for a gas. They're looking for hydrochloric acid. But all acids are aqueous, and we will pick up there next time. Memorize these things as soon as you can. They are going to be a big part of the test.